Okay, now that we have learned about how to draw lines and how to plot them, we might have noticed by now that all lines, they are lines, they are straight lines, but they look different. When I say they look different, I mean that they have a different angle at which they are drawn. So if you have a look at our three lines on the right over here, the green one, the blue, and the red one, firstly, they have all different angles compared to the horizontal. And at the same time, they are in different directions. Like the red and the blue, they are facing the same direction. So if we say we are going from point A to D, they are actually traveling upwards in the right direction, towards the right. For the green one, again, if we go from left to right, so from G to H, if we go from left to right, it's actually pointing downwards. Now, these things about lines is called the gradient. Okay, and gradient is the measure of its slope. So the gradient of a line basically means that it's the measure of a slope. How the slope changes depends on where the points are according to the relation of the line. Now, it's basically, you would write gradient as a number. So a number would represent the gradient of a line, and it indicates how steep the line is, whether it's very steep, does it have a sharp steepness, or it's very gradual. So something like that, for example, the brown one over there, if you compare that to this green line, which one is more steep, the brown or the green? I know you've all said green. So both the two lines will have a number that'll represent the steepness of the line. Now, what we need to think about that which number will be greater? The number that represents the green line steepness, the slope, or the number that represents the brown line slope? So think about it, and let's see how we can work out the gradient of a line and how the number represents how steep it is. So let's see. Okay, so there's a rule to find out the gradient of a line. There's a rule. Just like anything in maths, there's always a rule, and also the rule describes the relationship. Now, if we have a look at this triangle over there, okay, now if I draw a line, any line that's drawn, take for instance, imagine that you are going from point A to point D. You can go straight up that line. Imagine that these are steps, so these are staircases. Okay, so you'll go up and then across, up, across, up, across, up, across, up, across, and you'll keep doing that until you get to point D. Likewise, what you can do is you can take a total of all of the amounts that you have gone up, so up like that, and then take a total of all the amounts that you have gone across like that. That gives us the rise and the run of the line, which means how far have you gone up and how far you have gone across. So it's not only up, it's up or down, or left or right. So it's not only up, it can be up or down, left or right. Because if you have a look at the green line, to go from G to H, you'll be actually going down and then right. So it could be either or. So the rise and the run determines how much across we have traveled and how much up or down we have traveled to get from point A to B, which determines the slope of the line. Okay, now this gives us the formula, which is written over there. Okay, that is the gradient formula. And short form of writing gradient is M. Don't ask me right now why, but I'll tell you later why it's M. Now, you would have heard this before, you would have learned this before, and you might remember the gradient is equal to rise over run. Another way to write that, if I draw this, so if I have got this line over there, say just like these lines over here, if I draw that on a pair of axes, like, on coordinates with an x and y axis, then what does the rise represent? Which direction is rise in? The x direction or the y direction? What did you say? Did you all say the y direction? Correct. Yes, it is in the y direction. Okay, so that is the y direction. And what does the run represent then? Good job. Yes, it is in the x direction. Okay, now to go from one point to the other point, so to go from that point to that point, there's a difference. Because if you have a look, this point, the x coordinate is -2. And for that point, the x coordinate is 3. So how far has it traveled from A? Let's say this is point O. Okay, that's my perfect O there. So from A to O, it's traveled 1, 2, 3, 4, 5. Now, because it's a difference in distance, therefore, we actually say a change in x. And likewise, if you have a look at if you have a look at the rise, it goes from -5 to +5. So that's a difference of direction. That's a difference of that length of 10. So we say it's a change in y. Okay? Now the way we change in x, change in y, if you write that all the time, it becomes quite long for us to write that all the time. So instead of change in x, we write a triangle and x, which represents change in x. Likewise, change in y, a triangle and y, which is a change in y. So rise over run is also equal to, I'll just break that up slightly, a change in y over a change in x. Now I just want to tidy this up slightly. I didn't do this very neatly. Whoopsies. Okay, let's try this again. So, yep. Okay, which is equal to change in y over change in x. And as you can see, for all of these lines over there, so change in y is the rise and change in x is the run. Likewise, change in y is the rise and change in x is the run. Okay, now let's have a look at some of these lines. Now, you can either have a positive gradient or a negative gradient. Now, if you have a look at these two lines, that the first one is a positive gradient and the second one is a negative gradient. Can you think about why that's the case? Why is that a positive gradient and why is that a negative gradient? I know you got it. Because if you travel, so the trick is, if you travel from left to right, so if you're traveling from left to right, okay, so if you're traveling from, let's change the color. If you're going from left to right, so that means for the line, we're going from left to right, left to right. If we're going right and up, right is positive, up and positive. For the second line, we're going from left to right, left to right. So we're going to the right, positive, but we're going down, which is negative. So what we need to remember, this is what we need to remember. Going to the right and going up is positive. Going to the left and going down is negative. So either or, remember that whether it's going to the right or going up, positive, going to the left or going down is negative. So that's how you determine. And always remember that we're going from left to right. Okay? So if you look at that line, positive gradient, that line, negative gradient. Now, these little points, these little pointers will actually help you remember. So go through that whenever you have to determine whether it's negative or positive gradient. Now the other ones are, imagine if you've got a flat line, so flat, okay? Think of it like a flat piece of land. No slope, nothing. That means the gradient is 0. So that's why a horizontal line like this one, it has 0 gradient. And then think of a cliff. Maximum steepness, very, very steep. So steep that you can't define it. So therefore, a vertical line like this is undefined. And mathematically, if you think about it mathematically, so if you look at this point, okay, if you look at this line, the undefined gradient, I'll just choose a different color, I'll choose a brown. Now, the undefined gradient, okay, if you say take 2 points, so if you go rise over run, the rise is, say, from this point to that point. The rise means how far it's traveling in the vertical distance. So 1, 2, 3, 4. Okay, so for this undefined gradient, m equals change in y over change in x. Change in y is 4. Change in x, it's not going anywhere. There's no, this point is still on the same x in the same x value. So the change in x is actually 0. And we know that anything over 0 is always undefined. Okay, so that's mathematically looking at it. All right, let's look at this line, the one on the left. Okay, if you have a look at this line, we've just given a line. How do you find the gradient of this line? So let's calculate the gradient of this line. Now, whenever you're given a case like this, how would you know what's the rise over run? Which points do we take? If you look, the beginning point and the end point, they're not exactly on an x or y value. It's, you know, you have to estimate that one. You have to kind of guesstimate that one too. So, does the gradient change anywhere on the line? Does the slope change? When we go from there to there, look at the slope, and then look at the slope from there to there. Has it changed? Is it at the same angle? Yep, no, you all said yes. It's at the same angle and the gradient has not changed. So what that means is that wherever you travel on that line, the slope will be the same. So it's like a steady hill. You are having the same slope. It's not a roller coaster. It's not one of those, mountains which you are traveling at different slopes or walking at different slopes at different points. So a straight line means the gradient remains constant forever. What that means is that if you start at that point, you walk across 2, you'll go up 1.5. You walk across 2, go up 1.5. Walk across 2, go up 1.5. So same increments. Nothing changes. So the easy way is find 2 points, any 2 points which are exactly where you have got the exact coordinates. So let's see, which one have you picked? Oh, you've picked 5, 1 as, whoopsies, okay. So you've picked 5, 1 as one of them? Yeah, I would have picked that too. It's easy, so that point over there is 5, 1. Okay, what's your other point? Oh, did you put 0, -3? Awesome. That's what I did too. Great minds, people. Okay, so now what I would do, remember, M is equal to rise over run. Look at the line. Is it a positive line or a negative line? Look at the line. A positive line or negative? What did you say? Positive? Yes, correct. Okay. Now let's look at the rise over run. So the easy way to do is let's just make a little triangle. Okay, because that'll help us to determine the rise over run. Okay, so the rise is from there to there. What's the difference from 1, positive 1, to -3? So from that point, 1, 2, 3, 4. Okay, so this is our change in y, which is equal to 4. What's the difference in the run from that point to there? 1, 2, 3, 4, 5. So that's our change in x, which is equal to 5. So what's our, scroll down a little bit. What's our rise? It's 4. What's our run? It's 5. It's a positive line, so therefore our gradient is 4/5. Hope that makes sense. Okay, let's move on very quickly. It says, for each of the graphs, state whether the gradient is positive, negative, 0, or undefined. Then find the gradient where possible. So I'm going to leave this for you to try, and we'll check in class. There's 4 of them.